So now we'll move on to how we can define angles and some very rare question types involving the unit circle and angles and their different definition. There is something called, like, if you notice, we could also do it like this and we get the same sine of theta, the same height. And what's common about them? You've got the same basic angle. And the basic angle is the acute angle that this radius makes with the x-axis. And also, that basic angle, it could be the same of two different things. So what else would distinguish an angle? Another thing that could distinguish an angle is the quadrant it is in. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. So if we said it has a basic angle of 30 degrees, but it's in the second quadrant, then we would know it would be this. Except not quite. We wouldn't know the theta because we could equally go in the other direction. A clockwise rotation get the same thing. So that's why the direction also defines that angle. So there are essentially three things that will characterize angles: the direction, the basic angle, and the quadrant. And we could go from theta to those three things, or from those three things to theta. And so I'll just do some quick examples. And this is where I have a personal preference for using the unit circle rather than graphs. Say we take 100 degrees, and then we need to figure out basic angle, direction, and quadrant. So obviously this is honestly just a rough sketch. Now we already know the direction because the sign in front of the angle is positive. So that will be anti-clockwise. Now the basic angle, we've gone 100 degrees. Now what's going to be this angle here? Well, we use angles on a straight line, add to 180. So 180 minus 100 equals 80 degrees. And now the quadrant, we can see that this would be a 90 degrees, this would be 270 degrees, this would be 270 degrees, this would be 180 degrees, and then this would be 360 degrees, or 0, and then that would be 450, etc. If you had a really large number, honestly, what you'd do is you'd just have to keep adding up 90. You could keep circling on the... If it asked for a diagram, you'd have to keep doing a swirly spiral thing. But honestly, what I would do is I would divide 100 by 90. And then because it's given you something between a multiple of 1 and a multiple of 2, so it's between 1 and 2, then that would tell you that it is between 90 and 180. So it's in the second quadrant. For a bigger one like 750, you divide that by 90, you'll get, so 9 into 75, that's 8 and 1/3. That's between, because 8 is, you go 1, 2, 3, 4, then 1, 2, 3, think of it as going 1, 2, 3, 4 over and over again. 8, so that's between the fourth and the first, so that would be, you would get that in quadrant 1. And so we can say that's the second quadrant. Now, additionally, we could do this in radians, so that's what I will do now. We'll do this in radians. Let's have a look at minus 5 pi over 3 and the basic in the direction we can already know is clockwise because it is negative. In the basic angle, let's pull up the unit circle, and I'll say that because we're going anti-clockwise, I'll do it in negatives. This will be minus pi over 2. This will be minus pi. This is minus 3 pi over 2, and this is minus 2 pi, and also 0. And so now we need to do negative 5/3 pi. We know that that's greater than negative pi, so it'll be roughly and that's also bigger than negative 1.5 pi, which is this. This is about 1.67 pi. So it'll be roughly about here, and our direction looks like that. So basically we just need to find the difference between negative 2 pi and negative 5 over 3 pi. And if we do that, we do minus 5, minus 5 over 3 pi minus 2 over pi. That would give us pi over 3. So so that would be pi over 3, and that's our basic angle. And then the quadrant, we've already figured this one out, but you do this same thing a little bit, but rather than dividing by 90, you divide by pi over 2. So you get over 2, you get 2/3. And that, I've divided the basic angle. We don't want that. So that becomes negative 10 over 3, which is minus 3 and 1/3. And that's between 3 and 4. So when you go anti-clockwise, you go 1, 2, 3, 4. It'll be between here and here. So that would mean it's in the fourth one when you're doing clockwise rotation, but it's actually in the first quadrant, because quadrants are defined when you go anti-clockwise. And now you may also have to do the reverse. So what if you had to do B equals 32 degrees and is in the fourth quadrant, and it will also, because this there would be infinitely many solutions, for example, and this is also a way of clarifying the direction. It may give you a specific domain. So what if it said it was within 360 degrees and 720 degrees? That is a way of telling you, okay, it's an anti-clockwise rotation. So what I would do here, I would be thinking we start at 360 and then we go along 450 degrees, 540 degrees, 630 degrees, and then end with 720 degrees. Okay, we know it's in the fourth quadrant, and we need it to make a basic angle of 32 degrees. So it would be like this. And it's anti-clockwise rotation, so it's actually like this. So we figure out, okay, well, we know this is going to be 32 degrees, and remember our angles around a point. Angles at a point sum to 360, so we go 360 minus 32, and that is 328. And we remember, remember we started at 360, so we add the 2. And that gives us 688 degrees. And additionally, we could do a bit in radians as well. B equals pi over 6, fourth quadrant, minus 4 pi, minus 2 pi. And remember, this domain is telling us we're doing a clockwise rotation. So you'd pop up your unit circle again, and then think about it. Okay, we start at negative 2 pi. We go negative 2 1/2 pi, negative 3 pi, negative 3 1/2 pi, and that's negative 4 pi. And we want it to be in the fourth quadrant. Easy, that'll be the first one we do, and we want to have a basic angle of pi over 6. And because that is the fourth quadrant, then it's simply just going to be that. So our angle will end up being negative 2 pi, and remember we've done a clockwise rotation, so we are going to be subtracting that negative pi over 6, and that will get us negative 2 1/6 pi, and if we make that an improper fraction, that would be negative 13 over 6 pi. So that's how you define an angle, and that's how you can identify the angle in both degrees and radians from its characteristics, or give the characteristics of an angle.